Welcome back to lesson 14, where we are going to solve problems that involve limits of a ratio of functions divided by another functions that it will appear an indeterminate form like 0 divided by 0 or infinity divided by infinity. We will use L'Hopital rule to find the answer to the limits. So what it say L'Hopital rule? It say if you have two functions f and g, the quotient of this function, if this quotient, the limit when x goes to a, is on the form 0 divided by 0 or infinity divided by infinity, you can apply L'Hopital rule. And what it says L'Hopital rule is instead of calculating these limits, you can calculate the same limit when x goes to a, but instead of f of x, of f prime of x divided by g prime of x. So calculating this limit is equivalent to calculate this limit, only that this limit will appear to be easier to find the limits. Let's go to practice this problem. The 10 problems that we have to find the answer. Okay. Problem 1 say evaluate the limit when x goes to 0, x approach 0, of sine of 4x divided by sine of 3x. When x approach 0, sine of 4x approach 0, and sine of 3x approach 0. So this is an indeterminate form of the form 0 divided by 0. What it says L'Hopital rule is instead of calculating this limit, you can take the derivative of the numerator and divide by the derivative of the denominator and find the limits. So the limit when x goes to 0 of sine of 4x is the same limit when x goes to 0, but the derivative of sine of 4x is 4 times cosine of 4x, and the derivative of sine of 3x is 3 times cosine of 3x. So when x goes to 0, cosine of 0 tends to 1. Cosine of 0 here tends to 1. So this will tend to 4/3. So the limit is done. Let's go to the next. The next problem say, evaluate the limit when x goes to approach to 0 of arc sine of x divided by x. When x approach to 0, arc sine of x approach to 0 because the function arc sine of x is the inverse function of the sine of x, and the inverse function of the sine of x, remember sine of x do like this, and the inverse function is the image through the line y equal x. So it will do something like this. Okay? When it's restricted to pi divided by 2 and minus pi divided by 2, the arc sine of x. Okay? When this is the point pi divided by 2 comma 1, the point 1 comma pi divided by 2, it belongs to the inverse function. So this is the point 1 comma pi divided by 2. So the inverse function does like this. Let's go to make a nice picture for sine of x and cosine of x. Let me see if I can do a better picture. So I will do like this. So pi divided by 2 is here. Pi divided by 2 is 3.14 divided by 2 is 1.7. This is like 1.7 something. Okay, here is 1. And the function does like this. And here the function does, and here the function does like this. This is minus pi divided by 2, or minus 1.7, and the function, the value is minus 1. If this is 1.7, it means that 1 is something like here, and minus 1 is something like here. So this point, the point pi divided by 2, comma 1, sine of pi divided by 2 is 1, okay. This point appears in the inverse function as the point 1 comma pi divided by 2. 1 comma pi divided by 2 is 1 comma pi divided by 2 is 1.7. So it's here. So let's go to put it in yellow, the inverse function. So this is the point, and the other point is minus 1 comma pi divided by 2. So this is the function that appears. So the arc sine of x does like this. Well, like this, okay, like this. So this is the function arc sine of x. So at 0, arc sine of x is defined, is 0. At 0, sine of x is defined, is 0. But what is not defined is the quotient, arc sine of x divided by sine of x, by x. So the function y equal x is the vertical line with a slope 1. Okay. So how we will do these limits? Well, this limit, L'Hopital rules say, make the same limit when x goes to 0, but instead of arc sine of x, make the limits of the derivative of sine of arc sine of x divided by the derivative of the denominator. The derivative of the denominator is 1, and the derivative of arc sine of x is 1 divided by square root of 1 minus x squared. So if you take the limit when x goes to 0, when x goes to 0, the limit will tend to 1. So this limit is 1. Let's go to the next problem. Evaluate the limit when x goes to infinity, when of e to the x divided by x cubed. When x goes to infinity, e to the x goes to infinity, and x cubed goes to infinity. So the quotient will go to where? To infinity, to a number, to where? So what L'Hopital rules say, take the derivative of the numerator. The derivative of the numerator is e to the x. Take the derivative of the denominator. Well, this is infinity, of course. This is infinity divided by infinity. So it's an indeterminate form. So we have to apply L'Hopital rule, because we can apply L'Hopital rule because it's an indeterminate form. What is the limit of e to the x? E to the x. What is the limit of x cubed? 3x squared. Okay, but still, when x goes to infinity, e to the x goes to infinity, and this, the denominator will go to infinity, so it will be still an indeterminate for infinity divided by infinity. But if I keep doing L'Hopital rule again, and I keep doing L'Hopital rule again, I will find the limit when x goes to infinity of e to the x divided by 6. When x goes to infinity, e to the x goes to infinity, 1/6 of something that goes to infinity is infinity. So this limit is infinity. We will see that we can do the following thing also to find this limit. We can write e to the x as e to the x equal 1 plus x squared divided by 2 factorial plus x cubed divided by 3 factorial plus goes to infinity, x to the n divided by n factorial, but you never stop adding terms. This is the summation when n goes to infinity. So what will be e to the x divided by x? Well, it will be 1 divided by x plus 1 plus x divided by 2 factorial plus x squared divided by 3 factorial x n minus 1 divided by n factorial. Okay, when x goes to infinity, this limit, when x goes to infinity, this will go to 0, this will go to 1, this will go to infinity, this will go to infinity, and all the time will go to infinity, so at the end the sum will go to infinity. Now we are going to solve problem number 5. Let's say find the limit, natural log of x squared when x goes to 1. When x approaches to 1, natural log of 1 approach to 0. And when x approaches to 1, x squared minus 1 approach to 0. So this is of the form 0 divided by 0. So we can apply L'Hopital rule directly without doing any massage to the problem. We cannot do it. So because this is of the form 0 by 0, the L'Hopital rule say makes the derivative of the numerator, the derivative of natural log of x squared is 1 divided by the function, 1 divided by the function by the derivative of the function. So it's 2 divided by x. 1x will go 1x squared, whatever. So this is the derivative of the numerator. And the derivative of the denominator is 2x. So 2 divided by x divided by 2x is 1 divided by x squared. When x goes to 1, 1 divided by x squared goes to 1. And now the limit, we found that the limit is 1. Let's go to do the next. The next one say, evaluate the limit when x goes to infinity of x sine of 1 divided by x. When x approach infinity, the x approach infinity. When x approach infinity, the x approach infinity. And 1 divided by x approach 0, and sine of 1 divided by x approach 0 also, because sine of something very small is 0. So this is an indeterminate for infinity by 0. We cannot apply directly a L'Hopital rule unless we have infinity divided by infinity or 0 divided by 0. So we need to do something to the problem, to massage a little bit. So how we massage this problem? We write this, the x can be written like 1 divided, not by x. Well, x is not equal 1 divided. 5 is not equal 1 divided by 5, for sure. But 5 is equal 1 divided by 1 divided by 5. So the x is equal 1 divided by 1 divided by x. So let me erase here, not to make you to be confused. So x is equal, so we write the x here, this x, we write this x like 1 divided by 1 divided by x. So this is 1, the 1 is here, divided by 1 divided by x. And now we say when x goes to infinity, well, 1 divided by x goes to 0. Sine of something that goes to 0 goes to 0. And 1 divided by infinity goes to 0, so this is the form 0 divided by 0. So now I can apply L'Hopital rule. And L'Hopital rule say, make the same limits when x goes to infinity of the derivative of the numerator divided by the derivative of the denominator. The derivative of sine of 1 divided by x is cosine of 1 divided by x by the multiplied by the derivative of 1 divided by x, which is minus 1 divided by x squared. The derivative of 1 divided by x squared is minus 1 divided by x squared. So this will cancel with this, and it will have the limit when x goes to infinity of cosine of 1 divided by x. When x goes to infinity, 1 divided by infinity approaches 0 and cosine of something that approach 0 approach 1. So the limit is 1. Let's go to the next one. Evaluate the limit of x when x goes to infinity of x divided by 1 divided by x. This is an indeterminate form because when x goes to infinity, the x goes to infinity, and 1 divided by x approach 0. So infinity raised to 0, you don't know what number is this number. You don't know to whether it will approach this limit. So to know how to find how to which it will approach, we use L'Hopital rule. But we need to massage this problem in a way that I have to convert it into a problem that will be something 0 divided by 0. So if I start with this function and I take the natural log of x, will be 1 divided by x by the natural log of x. The natural log of y will be 1 divided by x by natural log of x. Now, when x goes to infinity, natural log of x goes to infinity, and x goes to infinity. So I can write this like natural log of x divided by x. So this will go to infinity when x goes to infinity, and x will go to infinity when x goes to infinity. And now I can apply L'Hopital rule. L'Hopital rule say when you are going to find the limit when x goes to infinity of natural log of x divided by x, and remember that this limit represents natural log of y. So when you do it in what way? You do the derivative of the numerator divided by the derivative of the denominator. So this will be the limit when x goes to infinity of 1 divided by x divided by 1. When x goes to infinity, 1 divided by x goes to 0. So it says that the natural log of y will go to 0. So y, who is y? Natural log in base e of something approach to 0 means that e is 0, e approaching 0 is y. So y approach e to the 0. Y approach 1. So the limit when x goes to infinity of x 1 divided by x approach 1. Wow! Impossible to do it without L'Hopital rule. Let's go to the next. The next problem say evaluate the limit when x goes to 0, when x goes to 0 of this function 1 plus x divided by 1 divided by x. It looks very similar to the previous function of the problem 7, x raised to 1 divided by x, but now it's an indeterminate form of the form when x goes to 0, 1 plus x approach 1, and 1 divided by x approach infinity. So this is an indeterminate form of the form 1 infinity. It's the same form that we saw in the previous problem. We saw the limit when x goes to infinity of x raised to the 1x is infinity raised to 0. It's different form than the other one. So you may think, well, if one number is the 1 goes to infinity, well, 1 goes to this must go to 1. But it doesn't, it's not true. When 1 goes to infinity, this indeterminate form, it will go to a precise number in the limit when x goes to 0. So we need to apply L'Hopital rule, but we need to find an indeterminate form in the form infinity divided by infinity or 0 divided by 0. So we do the same type of massage that we did in the previous problem. We name y equal 1 plus x raised to the 1 divided by x. So the natural log of y is 1 divided by x by the natural log of 1 plus x. So the natural log of y is natural log of 1 plus x divided by x. And now I will check if this is an indeterminate form of the type infinity divided by infinity or 0 divided by 0. When x goes to 0, the denominator goes to 0, approach 0. And when x goes to 0, natural log of 1 plus x tend to natural log of 1, which is 0. So it will be on the form 0 divided by 0. So I can apply natural L'Hopital rule to this quotient of those two functions. So the limit when x goes to 0 of natural log of y will be the derivative of the numerator. 1 divided by 1 plus x is the derivative of natural log of 1 plus x, divided by the derivative of the denominator 1. What is the limit when x goes to 0 plus of 1 divided by 1 plus x? Is 1. So what I have is the natural log of y, the limit when x goes to 0 of natural log of y, this tends to 1. So y, so e to the y, so in base e, so e1 is y. So y is e. So the solution of this limit is e. So our intuition that this will tend to 1, or maybe we will think that it will tend to infinity, is wrong. If you represent this function in your calculator, you will see that it will tend to the infinity, it will tend to e, to the number e. 1, if you represent the function 1 plus, when it will tend to 0 when x goes to 0. When x goes to 0, it will go to 1. So the function, let's go to try to guess how it will be the function. So this is the x, so the function f of x that I want to represent is the function x plus 1 or 1 plus x raised to the x. When x goes to infinity, for sure this will go to infinity. But when x goes to 0, the function will go to the number e. So it will do something like this. It will go to infinity, but in the limit when x approaches to 0, plus to the right, it will approach to e. Take a calculator, take a graphic calculator and represent this function. Okay, let's go to the problem. The next problem says evaluate this limit. When you want to evaluate this limit, this will tend when x goes to positive to from the right, something x is a number that is bigger than 2. So this is bigger than 2, so this is positive. X squared minus 4 when x approach to positive, the difference will be positive, so this will tend to infinity because 1 divided by 0 will tend to infinity. When x approach to 2, the x approach 2, but 2 minus 2 will approach to 0, 0 positive, 0 plus, 0 to the right, because you are putting here an x number that is bigger than 2. So you put in 2.001 approach to 2. So 2.001 minus 2 is something positive. So this is at indeterminate form of the form infinity minus infinity. So we need to massage this form to put it in the form 0 divided by 0 or infinity divided by 0. Or infinity divided by infinity, sorry. So how we will do? Well, we do a little bit of algebra here. We do a little bit of algebra. We do a little bit of algebra, very easy algebra. And now it's on the form 0 divided by 0. And now I can apply L'Hopital rule. L'Hopital rule say don't do this limit. Do the same limit of the derivative of the numerator divided by the derivative of the denominator. And this limit will tend to minus 3 half. And the problem is solved. Let's next problem. The next problem is try to teach you that sometimes L'Hopital rule will not work. Will not work because you will end in a cycle that after applying several times L'Hopital rule, you start with the same problem. For example, this is one of the examples that show you what happened. When x goes to pi divided by 2, tangent of pi divided by 2 goes to infinity, and secant of pi divided by 2 goes also to infinity. So this is of the form infinity divided by infinity. So you may say, okay, let's go to apply L'Hopital rule. The derivative of the numerator of tangent of x is secant square of x. The derivative of secant of x is secant tangent. So I will do this limit that looks simple. But as you see, this secant will cancel with this secant and will appear secant x divided by tangent x. That, as you see, is the inverse, is the reciprocal of this function. Now you will apply L'Hopital rule again. If you apply L'Hopital rule, the derivative, this is of the form, when x goes to pi divided by 2, secant x will go to infinity and tangent x will go to infinity. So this will be of the form infinity divided by infinity. So if you apply again L'Hopital rule, you say the derivative of the numerator is secant tangent, divided by the derivative of the denominator secant square. You cancel this secant with this square, and it will go tangent x divided by secant x. Oh, but I start where I have end. I have n where I have a start. So if I keep going, I will never end the loop. So to make this limit, the calculation of this limit, you need to do the following thing. Tangent of x is secant divided by cosine. Tangent of x is sine divided by cosine. And secant is the reciprocal of 1 divided, secant of x is 1 divided by cosine of x. Is the reciprocal of cosine of x. So if you divide sine of x divided by cosine of x divided by 1, this is sine of x. And the limit when x goes to pi divided by 2 of sine of x, this tends to 1. And the limit is being solved. Okay, let's go to the next lesson.